Hey guys, welcome back to the class of pre-calculus from Learn to Explain. And today we will introduce lecture 8. In lecture 8, we will be talking about the theorems to expand polynomials. We will introduce two theorems. One is using Pascal's triangle and the other one is called the binomial theorem. So we will basically use these theorems to expand binomials that are to the power greater than 3. Remember in previous class, we talked about the equations or the formulas on how to expand binomial square and binomial cube. Well, to expand a binomial to the power of 4 or 5, then it gets a little bit trickier, right? It is difficult to memorize the formula for every single expansion. So I will give you some tools for you to be able to expand a binomial without memorizing anything. Okay, so let's start with the first one. Let's introduce Pascal's triangle. You will be amazed by knowing how many uses Pascal's triangle has, but today we will just talk about the expansion of a binomial. Okay, so the first thing to do is to know how to build Pascal's triangle. This triangle that we have right here is Pascal's triangle. So the way we build it is as follows. We start with the first row, right? So we start naming it as row 0 or n equals to 0. And we write number 1, and on each side of number 1 we write 0 and 0. The next row, which is row 2, what we do is to add these two numbers. So 0 plus 1 is 1. 1 plus 0 is 1. And then we go to the next row. We add the two zeros on the side, and we do the same. 0 plus 1 is 1. 1 plus 1 is 2. 1 plus 0 is 1. And then we move on the next row, 0 and 0. And we start again. 0 plus 1 is 1. 1 and 2 is 3. 2 and 1 is 3. 1 and 0 is 1. And then the next row, we add 0 and 0. And we start the same. 0 plus 1 is 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4, and 1 plus 0 is 1. So do you see the pattern? You always add the two numbers and put the result in the middle of the other of your sum. Okay, so here we have the sum of all these numbers. And then you can do these steps infinitely, but you should pay attention to the level that you're interested in. Okay, so what I mean with that is these row numbers. Okay, so remember that we start with row 0 and then we go from there. Once you know how to build the Pascal's triangle, then the way we can expand a polynomial using Pascal's triangle is as follows. Let's say that you have a polynomial a binomial with the shape of a plus b to the power of 4. We have two options to solve this. We either do a plus b times a plus b times a plus b times a plus b and start solving this using distributed properties, right? It's going to take us a long time to solve all this. The other option is using Pascal's triangle. And the way we do it is that all these numbers that we have in Pascal's triangle are going to be our coefficient. Okay, so the first thing is to identify the power of our binomial. Is the power of 4. So it indicates that we have to go to the row equals to 4. Okay, so we are interested in this row. Once we have identified the row that we want, then we copy all those numbers. So we start with 1, then we have 4, then we have 6, then we have 4 again, and finally we have 1. Again, how do I know these are the numbers that I want? Because our power is 4, and then we go to row number 4, and these are my coefficients. Once I have all these coefficients, I add a times b to every single term. Okay, so identify here that we're building term by term, right? So ab, 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 b, and ab. Now, the next step that we have to do is we start putting the power in decreasing order for each letter. Okay, so let's start with A. We start with the power of 4 because it's the power that we have our binomial. So A here we have power of 4. Then we decrease by 1. So then this A it will be power of 3, power 2, 1, and 0. Okay, so now we do exactly the same thing but backwards with B. So we start power of 4, then power of 3, 2, 1, and 0. The signs in this case are going to be all positive because we have a positive right here. But let's say that we have a negative, okay? So let's delete this positive and write down a negative sign. So if we have a negative sign, then we start alternating, starting with positive. So the 1 right here will be positive, the 4 here will be negative, positive, negative, and positive. And this is the way we expand our binomial. The next thing we have to do is just to arrange it a little bit better because b to the 0 is just 1. So we have a to the 4 minus 4, a to the cube b plus 6a squared b squared minus 4ab cubed and plus b to the 4th power. And this will be the binomial expansion. And how do we do it? We did it using the Pascal's triangle. Okay, so let's do some exercises so we can practice this concept. Here we have a plus b to the power of 5. So now we have to go to row number 5 in Pascal's triangle, and our coefficients will be now 1, 5, 10, 10, 5, and 1. So what we have to do is to write them down. We have 1, 5, 10, 10, 5, and 1. Next step is to write the two terms that we have in our binomial, but multiplying in every single term in the expansion. So we have AB, 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 AB. Next step is to assign the power to our terms. Okay, so we start with A and we start with the power our binomial is. Okay, so we start with A and we start with 5 to the power of 5, and then we start decreasing by 1. So it is 4, 3, 2, 1, and 0. Now we do exactly the same, but the opposite side, starting with 5. We have 5, 4, 3, 2, 1, and 0. Next step is the signs. Since we have a plus here, everything in our binomial will be positive. Okay, so now let's arrange this expansion a little bit better. We have a to the fifth power plus 5a to the fourth power b plus 10a cubed b squared plus 10a squared b cubed plus 5ab to the power of fourth plus b to the fifth power. And this will be our binomial expansion. You see that we did it pretty fast using Pascal's triangle. Now let's do another example. We have here x minus y to the power of 4. Okay, so next thing to do is to get the coefficients. How do we get the coefficients? We look at the Pascal's triangle. Okay, so let's build Pascal's triangle really fast right here. We have 1, and then we have 1 and 1, and then we have 1, 2, and 1, and we have 1, 3, 3, and 1, and then we have 1, 4, 6, 4, and 1. Okay, how did I do this so fast? Well, remember, it's just you can assign 1 in the diagonals, or you could add the zeros on the side of every one and then start adding. Then this will be 1 plus 1 is 2, then 1 plus 2 is 3, same here. Then 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4. Okay? So now that we have Pascal's triangle and we build it pretty fast right here, then we start counting the rows. Remember, we start with row number 0, then row number 1, 2, 3, and 4. And we are interested in row number 4 because that's the power of our binomial. Now, let's start expanding our binomial. And the first step is to write the coefficients. So we have that our coefficients are going to be 1, 4, 6, 4, and 1 because they are the ones in row 4. And we write them down. So we have 1, 4, 6, 4, and 1. Next step, to write down the letters in, or the terms in our binomial. Okay, in this case we have x and y. So we have x, y, x, y, x, y, x, y, and x, y. Next step, to start assigning the powers in each term. We start from highest to lowest, and we start with the first term. Okay, so we start from 4, and that will be 4 x cubed, x squared, x, and x 0. Then we do exactly the same thing, but backwards with y. We have 4, 3, 2, 1, and 0. Now let's do the signs. The sign, since we have a negative sign right here, we start alternating, starting with positive. So we have positive, negative, positive, negative, positive. And now we just have to rearrange and write it a little bit prettier, our expansion. So we have x to the fourth power, because this goes to 1, minus 4 x cubed y plus 6x squared y squared minus 4x y cubed plus y to the fourth power. And that will be our binomial expansion. You see how we did the entire thing super fast just by using Pascal's triangle. So let's look at some tips on how we can use Pascal's triangle. Right? So the first thing to know is to identify the power of your binomial. Then the power of your binomial will be equal to the row that you need to consider to start your expansion. Once you have identified the root, then the numbers are going to be the coefficients. Then you start adding the two terms of your binomial, multiplying to each coefficient. So the first term and the second term in each term in your expansion. Then, so this will be term 1 and term 2. Once you have this, you start assigning the power in your expansion. How do you do this? Well, you start from highest to lowest in the first term, and then in the second, this is in the first term, and in the second term you go from lowest to highest, or you just start backwards. Once you have this, if your binomial is negative, if it is negative, then your signs alternate, and you start with positive. Okay, so basically these are the steps that you have to follow to expand your binomial using Pascal's triangle.